here are some scenarios. You save $5,000 today, how much would it be worth in 5 years? Second, you want $1,000 in 5 years, how much do you have to set aside today in one payment to get to that $1,000? Third, if you save $1,000 per month for 5 years, how much would you have saved after 5 years? Fourth, would you rather have, you just won the lotto, would you rather have 1.5 billion over 29 years, and that just means every year you take 1.5 billion divided by 29, or would you rather have $930 million today, right? Next, there's an apartment building for sale now for $5 million, and would it be wise to buy it, operate it for 3 years, then sell it for a profit? And we'll be looking at cash flows in that scenario. And sixth, if you borrow $1 million now to buy a 2-bedroom condo in San Francisco, what would you pay per month on your mortgage payments? So notice that each of these are fairly common business scenarios, and they all relate to money and time. So the first thing we should look at is what is going on here. In our new language, we see that the first scenario is a future value of a single payment. So we have a dollar amount today, and we're going out to 5 years. Second is it's the present value of a single payment. So the single payment is $1,000, but that's in 5 years. You want to bring it back to today. What is it worth today? Namely, present value. Third is a future value of an annuity. So that means we save and kind of put away $1,000 per month for 5 years. What is the future value that's accumulated after the 5 years? The fourth is a question of the present value of an annuity. Annuity is over 29 years, we'll get regular payments, and we're going to compare that to a lump sum payment now and say which one is more financially valuable to us. Fifth, this is a classic example of a net present value of an uneven cash flow. That's an investment. And last, we're computing the payment that would be due upon an annuity, in this case, a mortgage payment. So although these are kind of familiar sounding scenarios, or you can at least envision them to be typical financial or business scenarios, what we need to do is discern which of the tools that we just looked at can we use to attack those scenarios. So we're going to do each one of these in turn. First is, you have $5,000 today, how much is it worth in 5 years? Rate of interest. And so the formula is the future value equals PV times 1 plus the interest rate raised a number of years. So the recommendation is to draw a little picture. If I draw a picture, 5,000 today, and I save, so that's a negative, it would look like this, some negative number. And then in 5 years, it's going to be some big number, right? Hopefully much larger. So these are the two cash flows, and that's going to be our calculation. Okay, so let's do the first scenario, which is you save $5,000 today times 0, and you want to let it sit there for 5 years. So let's just put that in the grid. Cash flow today is negative 5,000, and there are no other subsequent cash flows, so I'll just, and the interest rate is 6%, 0.06. And the factor is plus 1, open parentheses, 1 plus that factor, lock it, raise it to the power of how many years are outstanding, are remaining, how far will be out, 5 years. Okay, so the PV is that times that. And that, in this case, is the answer since there are no other cash flows. The entire answer is captured right there, and that would be that $5,000 invested today would be worth $691 in 5 years at a rate of interest of 6%. Okay. The other is to use, again, I copied this forward, use the scenario of the function. And here we know the present value, and what's unknown is the future value. So it's this one. I know the PV, and I want to solve for the future value. So here, what is the rate of interest? Is 0.06. What is the number of periods? The number is 5. What are the payments? There are no subsequent payments. What's the PV? Negative 5,000. What is the future value? That's the question mark, right? So that's what we're going to solve. So the future value is equal FV, open parens, and look at the parameters. Rate is that, comma, number of periods is that, 5, comma, what are the payments? No payments because there's just one up front, comma. What is the present value? Negative 5,000. Close the parens because we accept the default. And the answer is 669113, which is exactly the same as that. So either the formula approach or the FV formula works well in this case. All right, so that's the first example. What is it worth in 5 years? It's worth $6,691, and we can arrive at it using a formula, which is frankly very simple in this case. Or we could use a function, Excel function of future value. All right, so that's the first example. Pretty straightforward. Next is we're going to, in the example I'm going to show how to use it if you had a calculator. I'm not going to show you this now in the lecture, but I'll put it in a slide deck so you can see it if you happen to own or want to own a financial calculator. All right, second is PV is a single payment. Now the scenario is you want $1,000 in 5 years, and we want to set aside one payment today to get to that dollar amount in 5 years. Interest rate is 6%. The formula is here. We've derived that one before. The PV equals future value divided by 1 plus interest rate raised to the n power. If we were to sketch the cash flows, $1,000 in 5 years. So you want to get that. So you want that's a positive number. We want $1,000 bucks, all right? And the question is, how much do you set aside in one payment right now at time 0? So some negative number. So what negative number now do we set aside so that it grows to be $1,000 in that amount of time? So that is the scenario. And so let's look at numbers. Again, we have two choices. We use the formula or a function. We want to set aside $5,000 here, and that's 1,000. And the interest rate is 0.06. And then the factor is plus 1 divided by, open parens, 1 plus the interest rate, lock it, raised to the 5th power. That's the factor. So every dollar is worth 74 cents today. So if we want $1,000, then we just multiply $1,000 times what it is worth today, and the answer is $747. So that means we would set aside $747 today, and it will grow over 5 years at a rate of 6% to hit our target number of $1,000. Right? So that's using this function or this formula. Next, we use the function. So here we'll use the PV function. So the rate of interest 0.06, the number of periods 5, the number of payments, the payment amount is 0 because there's a single payment. The PV is our question mark, so that's going to be our Excel function, and the FV is $1,000. Okay, so let's try this out. Equals PV, open parens. What is the rate? Comma. What is the period? 5, comma. What are the payments? 0, comma. And what is the FV? $1,000. Close parens. And you get the same number. So 747